So in this tutorial we are going to talk about three concepts that are very important in Java. First one is the method overloading or the constructor overloading. Then the second one is the use of static keyword and the use of final keyword. We have already used static keyword in the public main function. It was static, and now in this tutorial we will discover why we are making it as static, and we will also study about the final keyword. So first of all, let's take a look at the method overloading first. So first of all, I'm going to uh, give you an example in which case you're going to use method overloading. So let's suppose we want to calculate area. I'm going to write here calculate area. So if you want to calculate area of anything, of any shape, then there are different possibilities. So I'm going to draw some shapes here, for which you will have to create a function that will calculate the area of that shape. So here are the three shapes. So the first one is a square, the second one is a circle, and the last one is a rectangle. So let's suppose that we want to calculate the area of these three different shapes. You can see that these shapes will have different parameters. For example, size of the length of the square is a. So the area of the square is given by the formula a square, or a into a. If we take an example of a circle, we are given a radius, and to calculate the area of the circle we will use the formula pi into r into r. In case of a rectangle, we have length and the breadth. So the area of rectangle will become length into breadth. So you can see that all of these formulas are calculating, they are basically calculating the area of the given shape, but these all shapes are using different parameters. As you can see here, one is using radius, then this one takes two parameters, length and breadth, and this will take only one parameter. So we will have to solve this problem. So what we are just going to do is, let's suppose there are two programmers. So let's suppose this is a programmer 1. I'm going to write here P1, and there is another programmer which is P2. So the programmer P1 does not know what is method overloading. So he does not know what is method overloading, but the programmer 2 knows the approach of method overloading. So let's see what the programmer 1 will do. So the programmer 1 will create, first he will create a class shape, and then what he is going to do is he is going to create three different functions with three different names. For example, to calculate the area of square, he will create a function void area square, and since square is taking only one parameter, he is going to write here int a, and then he will perform the operation in this place. Then for the shape circle, he is going to create another function with a different name as void area circle. And in the case of circle, we will have to take radius. So let's suppose it is a float value. So float radius, and then similarly he is going to perform the calculation here. So in the case of rectangle, he will again create a function which is void area rectangle, and again he is going to pass two parameters, which is the length and the breadth, and then he will perform the operation here. And then in the main function he will create an object of this shape class, and he will call and the user can now call a specific function to calculate the area of square or circle or rectangle. But the programmer too, since he knows the usage of method overloading, he says that we can reduce this much complexity of using different names for a function which is doing a same thing, and the same thing is calculating the area. So you can see that all these functions they're actually calculating the area. So the programmer too says that, okay, what I'm just going to do is I will also create a class shape, but instead of creating different name functions, I'm going to create a same function with the name void area. So let's suppose you want to calculate the area of square. You will write int a in this function, and then you will calculate the area of square here. So if you want to calculate the area of circle, you will give the parameter float radius. I'm going to write it r here, and then you will perform the calculation here. And similarly, for calculating the area of rectangle, we are again going to call the same function area, but we are going to use two parameters in this case. So you can see the two approaches on this side. This is the approach which is done by programmer 1, which does not know what is method overloading, but the programmer 2 knows method overloading. So what he did is he used the same name in order to reduce the complexity in using different names and handling them in calling. So he used the same name, but he's calling them using different parameters. So that's the basic idea of method overloading, which says use same name but with different parameters. So there are two ways in making these parameters different. First is the number of parameters. As you can see that in this program, in this function, we are assigning two parameters, whereas in this function we are assigning only one parameter. So now the compiler will be able to distinguish between these two functions. So this is the first way, is the number of parameters. But you can see that in these two functions, which is this one and this one, the number of parameters are same. So how will the user distinguish these two functions? So let's suppose the user creates an object S of this class, and now he wants to calculate the area of the circle, and so the radius is given. So let's suppose the radius is 5.39, ending with a semicolon. So now the programmer 1 asks programmer 2 a very important question. He says that, okay, you're going to create the same, you're going to assign the same name but different parameters, but how will the compiler, or how will the user be able to distinguish between all of these area function? So the answer is that the compiler will start doing the matching work. at the time of the function call. So this is the function call. So this is the function call, and remember that the function call is done in the main function. So I'm just going to write here main function. So in the main function, whenever you will use the object of this class shape and you will call this area function using one parameter, then it is going to match it with that function which has the same parameter, the same number of parameters. So now in this case you can see that the number of parameter is 1. So there are two different functions, but they have the same number of parameters, which is 1. So how will the compiler distinguish between these two functions? Then the answer is that it will match it using the data type of the parameters. So data type of parameters. So you can see here that in this case we are passing the value 5.39, which is a float value. So what the compiler is going to do is he's going to match the area function which is accepting the parameter as float. So the compiler will call this function. It will reject these two functions. So this is the basic idea behind method overloading. We are going to use the same name because they have the same purpose of calculating the area, but we are going to use different parameters, different number of parameters, or different data types of parameters to call a particular version of that function. So you can implement this in the IDE, in the Eclipse IDE, and see how the compiler will call the particular function. So you can also create some more function calls like s.area, and this time you can provide it with two values like 7 and 9. So it will call this function because this function is accepting two parameters and they both are of integer types. So now it will calculate the area of the rectangle. So that is known as method overloading. So since I have already created the program in Eclipse IDE, so let's take a look and let's run it. So here is the program. You can see that we have created a class shape, and these are the three functions that we have created. One is to calculate the area of rectangle, then square, then circle, and you can see that all of them are having same name but different number of parameters and also different data types of the parameters. In the main function, you can see here I've created an object of this class shape. So now let's suppose the user wants to calculate the area of a square. So you can see that when I will write s dot, it is already showing me that you can call any these three of functions. You can call the area float radius function, which will call this one, and you can similarly call the area int a, which will calculate the area of the square, and similarly this function will calculate the area of rectangle. So this is the basic idea behind method overloading. So now let's suppose the user wants to calculate the area of circle. So we will select this one. So I can write here area, and let's give it a float value. So I've created a function call using this. So let's make it 3 first. So let's calculate the area of square. So you can see that there are 3 area functions, but now it will call the function area which has one number of parameters and the data type should be int, so it will call this function. So let's run this program and see the output of this program. So you can see that the output is area of square is 9, so it has called this one. So this is how function overloading works. Similarly, if you want to calculate the area of the circle, just provide it with some decimal value, and since this is a double value, so I'm going to write here double. So now it will call this function also, and similarly you can also call the area function with two different parameters. So let me just call the area function also. So that's it. So let's run this final program and see what will be the output. So as you can see that called the respective area functions. So that's how function overloading works. You can apply the same concept in the constructor overloading, since constructor is also a method, but the difference is that you do not need to call it like this. It will be called automatically when its object will be called. So what you will have to do is, in order to distinguish different constructors with the same name, you are going to write these parameters or the different types of parameters in these braces. So it will just, so the compiler will just match it with the respective constructor and it will call that constructor. So the same idea. So let's now talk about this static keyword. So you can see that this static has been applied to this main function. So when we have discussed the most basic thing, which is that if you want to call a function, you will first have to create an object of this class, and then you will have to use the dot operator to call that particular function. You can see that this area function is called because we have created an object of that class and we have used a dot operator to call that method. But you can see that this is also a class ThinkX and it has a main function. Main function is also a same function as area or like that. It is also a method, right? So you can see that we are not creating any object of this class ThinkX and we're not even calling this main function. It is called automatically. So it is called automatically because of this static keyword. So static keyword is used when you want to call a particular function or when you want to allocate the particular function in main memory so that it can start executing. So you will apply static in front of it. So if you will apply static in front of a function, you do not need to create the object of this class and you do not need to call it like this. Writing static in front of a method will just the compiler will just execute it without even, you do not need to create the object or you do not need to call that function. Similarly, if you will apply static in front of any variable, so let's suppose you will create a variable static int a equals 10. So when you will apply static in front of a variable, then this means this variable a will be assigned in the main memory without even calling this the object of this class. So you can see here that in this class area function, if I will write variable inside this shape function, let's suppose I create int b comma c. So if I've created two variables in this class shape, then remember that these variables will not be assigned. So I will write here not allocated in main memory or in the memory. So if you will not create an object of this class shape, then it will not allocate these two variables in the main memory. So if you want to allocate a particular variable in the main memory, and the need to allocate why do we need to allocate a particular variable in the main memory? The reason is that without allocating a particular variable in the main memory, your program cannot use that variable. So since we are not creating any object of this class ThinkX, we have applied static in front of this variable int a. So whenever the compiler will run this class, it will automatically assign the variable as 10 and it will allocate it in the main memory. And we know that for every program to continue its execution, the variables and the function should be in the main memory. Then only you can execute it. So that's the main use of the static keyword. The next keyword is the final keyword. So I will write it here. So let's suppose I create a variable int b equals 20, and you can see that I have written final here. So final basically has two functions. In this case, it makes variable b as constant. So using final keyword is just using a const, which is a constant keyword in C++. So it will make this variable final. That means it is constant. Its value cannot be changed. So this is one major important use of this final keyword. Another function which is which we are going to discuss it in the chapter inheritance. So if you will apply final in front of a variable, as of now you can just understand it as it will be assigned as a constant. The second use comes in inheritance, and in the next tutorial we are going to cover the inheritance topic, and we will discuss how we can inherit a particular class. We will see how this object oriented approach of inheritance is implemented in Java. And you can see that this method overloading is using same name but they are performing different function is an object oriented approach which is known as polymorphism. So I'm going to write here polymorphism using same name but different parameters so that it can have different keys is polymorphism. So basically polymorphism is method overloading, or you can implement the polymorphism object oriented approach using method overloading. So that's it. Thanks for watching.